All right, so this video is to go over some of the review that we did in class on Wednesday for those that were absent. Something that we talked about on Wednesday was the idea of conservation of mass. So anytime you have a chemical reaction take place, mass is conserved. When you make something new, as in the form of products, it's not like you created it from nothing. You created it from the matter that was in the reactants. So therefore, the mass of the reactants has to equal the mass of the products. So even though atoms are rearranged, they're the same atoms, just in a different arrangement. So experimentally, we would see this if we measured the mass of our reactants and compare it to the mass of the products. Granted, you'd have to have pretty sensitive instruments and really good separation and isolation techniques in order to do that. But scientists did do that in the 1700s, and one such scientist was able to take mercury oxide, whose chemical formula is HgO, that's mercury oxide, that was the reactant, and break that down into mercury plus oxygen. Let's balance the equation here. All right. And so what the scientist did was he realized that, or he weighed mass the beginning reactant amount, the mercury oxide, and it was 216 grams of mercury oxide. And after the chemical change, after the reaction, he had isolated 200 grams of mercury. And how many grams of oxygen do you think that he was able to get? Well, it had to be 16 grams because mass is conserved. The mass of the reactants has to equal the mass of the products. There's a video on TED Ed video that you might find helpful to watch. And if you just type in Google TED Ed Law of Conservation of Mass, you'll come up with a video that kind of illustrates this concept a little bit more clearly. But let's go ahead and do a practice problem from your book. So if you go to page 65 in your textbook, there's some practice problems that help you kind of deduce the number of grams of a reactant or a product based on a laboratory problem. So we'll look at number 6 to start with. On page 65 it says, from a laboratory process designed to separate water into hydrogen and oxygen gas. So we had water was our starting material, and the products were hydrogen gas and oxygen gas. So let me balance this equation real quickly. All right. So it says a student collected 10 grams of hydrogen. Put that down here, 10 grams of hydrogen, and 79.4 grams of oxygen. How much water was originally involved in the process? So we want to know. Well, remember, the mass of the reactants has to equal the mass of the products. So that unknown is just 10 grams plus 79.4, so 89.4 grams. And that would be how much water you had to begin with. Let's try another problem. Go ahead and look at number 7 on the same page. A student carefully placed 15.6 grams of sodium in a reactor supplied with an excess quantity of chlorine gas. And don't worry if you don't know the chemical formulas. You can write out the words like sodium and chlorine. When the reaction was complete, the student obtained 39.7 grams of sodium chloride. And the question is, how many grams of chlorine gas reacted? So our product was 39.7. This has to be equal to our reactants. And it says sodium, when the reaction was complete. So all the sodium was used up with an excess of chlorine gas. The reaction completely went from sodium and chlorine to sodium chloride. So my unknown here is what I'm trying to solve for. So it's just like an algebraic equation where you have, you could put in any variable there. X would be an example because that's our unknown. So to solve that, you just have to isolate X. So I'm going to subtract 15.6 grams from both sides of my equation. And my unknown amount is 24.1 grams. And that's how much chlorine gas I had to start with. So the big thing to remember is that the mass of your reactants has to equal the mass of your products. And the second law that we looked at on Wednesday in review was the law of definite proportions. Basically, this is saying that the elements that make up compounds are always going to combine in the same proportion, and that's by mass. And you can think of a ratio too. But if we have, for example, water, the compound water, you're always going to have the same proportion of hydrogen atoms to oxygen atoms, or mass in hydrogen to mass in oxygen. So for example, if you had an 18-gram sample of water, 2 grams of that is hydrogen, and 16 grams of that is oxygen. Okay. So say we had a, just going to double it to make it easy, a 36-gram sample of water. Then we have the same proportion of hydrogen, so we doubled it, so there's 4 grams of hydrogen here. And there's 32 grams of oxygen. So notice, depending on the size of your sample, the number of grams that you have is going to change. However, what doesn't change is the percent by mass of hydrogen in water. So let's figure out what the percent by mass is. We use an equation for that to represent it. The percent by mass of any element from a compound is just the percent mass of that element, we'll put E for element, is equal to the grams of that element divided by the grams of the compound times 100. So if I want to know the percent mass of hydrogen in water, I would say, looking at my first example here, I have 2 grams of hydrogen in water, and the total number of grams in that compound is 18. That's of water. So I would divide and then multiply by 100. And let me get my calculator out real quick. Wasn't really prepared to do this. So let's see. 2 divided by 18, not the best of mental math, is 0.11111 times 100. And so we're going to get that percent mass of hydrogen in water is always going to be 11.1%. So even when we have a 36-gram sample, 4 grams, again, is going to be 11.1%. So we can try that out. Let's use a different color here. So if I look at this larger sample, remember to figure out the percent mass of that element. You're going to have grams of that element. So hydrogen, we had 4 divided by 36 grams of water times 100. 4 divided by 36 times 100. And you again get 11.1%. So that's going to be consistent with any sample of water. It's always going to be 11.1%. So then what's going to be our percent contributed by oxygen? You could carry out that equation again, or we just know that hydrogen and oxygen are the only 2 elements in this compound. So if 11.1% is hydrogen, then the percent contributed by oxygen must be 100% minus 11.1%. And I mean, you could do the math if you want to do the equation for practice. but that would make the percent oxygen 88.9%, and that will always be the same. So let's practice a couple of these percent by mass problems. And you find this in your textbook on page 76. So if you want to pause and do one of the practice problems and then come back and listen to the explanation, that's great. Number 20, we'll look at first. It says a 78-gram sample of an unknown compound. We don't know what that is. You could say compound X. Contains 12.4 grams of hydrogen. What is the percent mass of hydrogen in that compound? So the percent mass of hydrogen is equal to the grams of, 12.4 grams of hydrogen divided by the total in the compound. I'm going to fix that. It's going to bother me. Okay. So we had 12.4 grams of hydrogen divided by 78 grams of your compound X, we'll say, times 100. And we calculate that 12.4 divided by 78 times 100 is going to give us 15.9% hydrogen. And remember, you want to round it to 3 significant figures because that's the least precise measurement we have in our equation. All right, we'll do one more for practice if you want to follow along. Let's look at number 21. And that's again on page 76. If 1 gram of hydrogen reacts completely, so 1 gram of hydrogen reacts completely with 19 grams of fluorine, so those are my reactants. What is the percent by mass of hydrogen in the compound that is formed? So we don't know, they don't give us the name of the compound that's formed, but I'm pretty sure it'd be hydrogen fluoride there. We want to know what the percent of hydrogen is, percent by mass. So the percent by mass of hydrogen is here, and I want, again, in my equation, the percent mass of hydrogen is equal to the mass of hydrogen divided by the mass of the compound. Well, what is the mass of the compound? Times 100. What is this quantity? Well, we have to use our law of conservation of mass to determine what that is. So remember, your reactants have to have the same mass as your products over here. So 1 gram plus 19 grams equals 20 grams. So I can then plug in my numbers here. Mass of hydrogen is 1 gram over a total of 20 grams in the compound times 100. And that should give you 5% mass hydrogen in that compound. So that compound is 5% hydrogen. And then what would it be? What would be the mass of fluorine? Fluorine would then have to be 95% of the mass was contributed by fluorine. And that makes sense, as you'll learn later, because fluorine is a much larger atom than hydrogen. It has more protons and neutrons, which give it more mass. So the review questions that I had set up to review for the Chapter 3 test on page 82, numbers 32, 34, 37, 39, 48, 61, 64, 67, 71. So if you could have these done before you come to class on Friday, we'll correct them in class. Go over any questions that you have on those then. Thanks, and I hope that was helpful.